Good morning, grade 10s. I hope you guys are all well and that you're keeping safe and healthy and that you're keeping up to date with your work. The first thing that you need to do today is download the memo for yesterday's homework. You will see there is a file that says memo dated the 6th of May. If you can just download that and mark your work, please. And then we're carrying on today with Euclidean Geometry, and we are going to be doing Theorem 2 today. So Theorem 2, we are going to be proving that the diagonals of a parallelogram bisect each other. Now this theorem is used when you're given a parallelogram. So they will state A, B, C, D is a parallelogram. This proof needs to be learnt, just like Theorem 1, it is examinable. So you might need to memorize it, and actually they would say to state Theorem 2. And you would have to be able to write it down and prove it. So if you have a look there, it says given parallelogram ABCD. So there they've told you it's a parallelogram with AB is parallel to DC. So we're looking at the two vertical lines, AB parallel to DC. And they tell you that AD is parallel to BC. So we're looking at the top and the bottom line. They are parallel as well. And then we are required to prove that AE is equal to EC and BE is equal to ED. Now you'll note on that diagram we don't have a point E, and that's going to be our starting point. The first thing we're going to do is construct diagonals. Right, so as I said, the first thing that we are going to do is we are going to construct diagonals. So you can see there in the drawing that AC, the first diagonal, has been drawn, and BD, the second, has been drawn. Now please keep in mind that we are trying to prove that the diagonals bisect each other. So what we are trying to prove is that the one diagonal cuts the other diagonal in half and vice versa. So in essence what we're proving is that AE is equal to EC and that BE is equal to ED. Okay, so we are trying to prove that those sides are equal to each other. So once again, you need to think we've got two triangles here, and we're trying to prove that two of the sides of the one triangle are equal to two of the sides of the other triangle. And that should make you think of congruency. So if you have a look at the proof there, the statement and reason, it says in triangle ABE, so we're looking at the one on the left-hand side, and triangle CDE, the one on the right-hand side. The first thing you should see is that A2 is equal to C1, and that's alternate angles. The second thing is that B1 is equal to D2, and once again, that's alternate angles. So far, we've got two angles that are equal. And then you can see they told you it's a parallelogram. We know with a parallelogram, the opposite sides are equal. So you can see that AB is equal to DC. So far we have two angles and we have a side, which is enough to prove congruency. So therefore, triangle ABE is congruent to triangle CDE, our reason side angle angle. And because they're congruent, it means that all three sides on the one triangle are equal to all three sides on the other triangle. It means that all three angles in the one triangle are equal to all three angles of the other triangle. So therefore, we prove then that AE is equal to EC and BE is equal to ED. So what we have proven is that the diagonals bisect each other. Remember, bisect means to cut in half. Moving now to the converse of Theorem 2. So the Theorem 2 said, because it is a parallelogram, we proved that the diagonals bisect each other. Now the converse says, if you have a quadrilateral where the diagonals bisect each other, it must be a parallelogram. So in this converse, you are going to be asked to prove that it is a parallelogram. So they will tell you it is a quadrilateral, and you will be asked to prove that it is a parallelogram. And the way we do this is we will prove that the diagonals bisect each other, and if the diagonals bisect each other, we know that is a property of a parallelogram, and therefore it must be a parallelogram. So if you look at example 1, I'm going to do this with you in a video. It says that diagonals AC and BD of parallelogram ABCD intersect at point M. It then gives you a bit of information, but I'm going to transfer over to a video and actually do this one with you. Okay, grade 10. So the question says to us that ABCD is a parallelogram. I've just highlighted that in red. They tell us that AP is equal to QC. They tell us that AP is equal to 150 millimeters. They tell us that AC is equal to 600 millimeters. And what they're doing is they're asking us to prove that PBQD is a parallelogram. So PBQD is a parallelogram. Now, before we even get to that, I'm going to focus on my big parallelogram first of all. They tell me it's a parallelogram, so that should bring to mind a couple of things. Firstly, that the opposite sides are equal and parallel, the opposite angles are equal, and the diagonals bisect each other. So I'm just going to highlight my diagonals here. Excuse the skew lines. So they are my diagonals, and they bisect each other, which means that this line BD cuts AC in half. Okay, so that means that AM is equal to MC. So that's going to be my starting point. I'm going to say AM is equal to MC. My reason would be the diagonals of parallelogram ABCD bisect each other. Okay, now if we look at this line AM and MC, if you go into the information they've given us, they've told us that AC, so this whole diagonal, is equal to 600. So they tell us that AC is equal to 600 millimeters, and that would be given. Okay, so what I'm going to do here, this whole line AC is equal to 600. But we know that AM is equal to MC, which means this should be 300, and that over there should be 300. Okay, so the way I'm going to write that is I'm then going to say AM is equal to MC, which is equal to 300. Okay, but now if we take it a little bit further, they also tell us that AP is equal to QC. So AP, that line there, is equal to QC, that line there. And they tell us that AP is equal to 150. So this over here is 150, and that is 150 because they're equal. Okay, so now logically you should see that if these two sides are equal to each other, AM and MC, and AP is equal to QC, you should see that PM is equal to MQ. And the way we would work it out is you would say the whole length of AM, which is 300, minus the length of AP, which is 150, leaves you with 150. So PM is equal to 150. And the same goes this side. I've got the whole of MC is 300, but QC is 150. So 300 minus 150 gives me 150. So what we've done there is we have now proven that AP is equal to QC, which is equal to 150. That was given. And therefore, PM is equal to MQ, which is equal to 150. Okay, so those are all equal to 150 degrees. Okay, then I'm going to highlight sorry, can you see there? I'm going to highlight the parallelogram that they now want us to work with. Let me just zoom out a bit. Okay, so now they are asking us to prove that PBQD is a parallelogram. So I'm just going to color in that parallelogram. Okay, and what we should notice in this parallelogram is that diagonals of my parallelogram PBQD, the first set of diagonals is BM and MD, and we already know that those are equal to each other because they are the diagonals of parallelogram ABCD. The second set of diagonals of the smaller parallelogram is PM and MQ, and we've already proven that PM and MQ are equal. So what you can see is that the diagonals of parallelogram PBQD, the diagonals bisect each other, which means cut them in half, which means that the diagonals would be equal. So that's when they cut in half, that each side would be equal. So that is equal to that, and this is equal to that. Okay, so what we're going to do then, I'm just going to move it up. We already know that BM is equal to MD. That's because the diagonals of parallelogram ABCD bisect each other. So that's given. So therefore, PM is equal to MQ. That was what we proved here, being that they are, just going to move it up, it doesn't seem. Okay, so PM is equal to MQ. We proved that here, they're each equal to 150. And you can see that BM is equal to MD. Okay, so that we've proven. So basically, like I said, the diagonals of the small parallelogram are equal to each other. So because that is then proven that the diagonals bisect each other of the smaller parallelogram, so therefore PBQD is a parallelogram. And the reason is that we proved that the diagonals bisect each other. Okay, so there we have proven that PBQD is a parallelogram. Right, grade 10s. Now that we've seen how Theorem 2 and its converse works, we are going to do one more example from your textbook. So I'm on page 195, exercise 3, and I'm going to do question 1 with you. And I'm going to switch over to a video and we'll do this together quickly. Okay, grade 10. So the next example that I'm going to do with you is actually one of your homework questions. So it's exercise 3, question 1 on page 195. So I've drawn the diagram there for you, and they have told us that ABCD is a parallelogram. So I'm just going to highlight it. So ABCD is a parallelogram. They've also told us that ABDE, so I'm going to draw it in another color, ABDE is also a parallelogram. And the third thing they've told us is that DF is equal to BD. And what they're asking us to prove is that BC FE is a parallelogram. So they're asking us to prove that this is a parallelogram. Now I'm going to start off with the red one, BCFE. They want us to prove that that is a parallelogram.
So we know that there are several ways of proving a parallelogram. First is that the opposite sides are opposite. Second, opposite sides are parallel. Third, opposite angles are equal. Fourth, diagonals bisect each other, etc., etc. So if I look at this parallelogram, I can see for E, B, C, F. I already can see that my diagonals A, F, this is equal, BF, sorry, BD is equal to DF, that's given. And what I need to basically prove now is that ED is equal to DC. Okay, so the way I'm going to do this, I'm going to start off by seeing that AB is equal to ED. Why do I say that? Because ABDE is a parallelogram, and I know that in a parallelogram the opposite sides are equal. So my starting point would be AB is equal to ED. My reason would be opposite sides of parallelogram ABDE are equal. So this side is equal to that side. The second thing that I'm going to notice is my blue parallelogram. That AB in my blue parallelogram is equal to DC. Why do I say that? Because in this blue parallelogram, my opposite sides are equal. So I can say that AB is equal to CD. My reason would be opposite sides of parallelogram, and it's A, B, C, D are equal. Okay, now have a look here. I've said that AB is equal to ED. AB is also equal to CD. So logically you should see that ED is equal to CD. So you would then say therefore ED is equal to CD. Now if you look at your diagram, you've got ED is equal to CD. So you can see it is the diagonals of this red parallelogram. Okay, so they've asked us to prove that BCFE is a parallelogram. We're doing so by proving that the diagonals bisect each other. We can already see that BD and DF are equal, and we've just proven now that ED and DC are equal, which means that your diagonals bisect each other, which means that it is a palm. So I'm just going to write in there that BD is equal to DF. That was given. We've proven, let's say the and ED is equal to CD. That we proved now. So therefore BCFE is a palm, and my reason would be diagonals bisect each other. Okay.
And lastly for today is your homework. Mind Action Series textbook, page 195, exercise 3. It says there question 1, 2, and 3, but please remember I have done question 1 with you, so make sure it is in your book, but I have done it with you. And then please remember, if you need help or if you're stuck with something, please WhatsApp or email your teacher. We are here to help you. Have a wonderful day and see you guys tomorrow.